Welcome to Sundar's lecture. This is lecture number 13, and in the last class, uh, we have taken a new topic, right? Nodal voltage analysis method, and we try to solve the problem. And the ultimate aim to get what is the current flowing through all the resistors, right? But we are approaching with a different method, which is nodal voltage analysis method, and we have taken the matrix method to solve this problem. And we can also solve this problem by using Kirchhoff's current law, but we have started with the matrix method. Then we will go for Kirchhoff's current law, applying Kirchhoff's current law to solve the problems by nodal voltage analysis method, right? So what are all the things we have seen? This is the problem we have taken, and I have told you have to go for nodes. How many nodes are there in this circuit? You see, we know that three or more branches connecting at a junction is called a node. So you see, this is a node, and this is a node, and this is also a node. See, this point is a node, and this point is also a node. And I have told you one shortcut method. If you see any two nodes like this, which means there are three branches connecting at this point, so I am calling this as node. And also you can see here there are three branches connecting at this junction also, and you can say that this is also a node. But if there is no elements connected between these two nodes, then you consider these two nodes as a single node. Even if it is coming here, then you have to do that. Then you have to do that, right? Okay, fine. Anyhow, so I have told you that take any one node as a reference node. Always you take this as a reference node, since every negatives are connected to this point, so we always take this node as a reference node. It is not mandatory. You see, this is not mandatory thing to take this as a reference node. No, not at all necessary, right? Anyhow, so we have taken this as a reference node, and we have formed the matrix from gv is equal to I, and g1 g11 g12 g21 g22 and all these kind of things we have written to find what is VA and VB, which means VA here is what? With respect to O, with respect to the reference node. Whatever the reference node you are taking, then the voltage at the other nodes will be respect to that reference node. That you have to understand, right? So we have found what is VAO and what is VBO, right? Here you see, what is the thing we have found here? Voltage between these 2 points. That means A and O point is 3.34 volt, and voltage between this point B and O is 2.40. So this is what we have found, right? With this knowledge, we are going to get what is the current in all the resistors. So for that, I will draw the diagram again. See, we have taken the problem now, and we have written the what is VAO and what is VBO, right? Now, you see, we have seen this topic already, voltage between any 2 points. That is why I have repeatedly told you, this voltage between any 2 points is a very important topic. Wherever you go, you can easily approach the electric circuits using voltage between any 2 points, right? We are going to use voltage between any 2 points now. Now I will tell you the thing, right? See, this is O, this is commonly O, right? This is A. Now you see, we know what is VAO, which means the voltage between this point and this point is 3.34, right? You can go from this point to this point, that is also VAO. And if you go straight away to this point, that is also VAO. And you can go through this point, here you come, that is VBO, and you go here, that will be VAO, right? Voltage between any 2 points via any path will be equal. That is the thing we have already seen. Right now, I try to find what are all the voltage, what are all the currents in each resistance, right? First I will take with a different color, maybe red. See, I am going to find what is the current in this 2 ohms resistor. To find current in this 2 ohms resistor, what you do, you just assume the current direction. Maybe I am writing it as I through 2 ohms, right? I through 2 ohms, right? This is assumed by me. Try to understand. This current direction is assumed by me, and if I am getting a negative value, I can reverse it. That's all, right? Now what you do, you write the expression for VAO via this path, right? I am writing here. So VAO can be written as, you see, start from O and go to A. If you have any doubts, you please refer my previous lectures. Voltage between any 2 points via any path will be equal. That is what we have explained in the lecture number 3. I will give the lecture link in the description. Anyhow, so start from this point O, come here, and you go here. You are going in this direction. So from you are traveling from minus to plus. So what you have to do? You have to put plus, you have to put plus 10, right? No problem. And you're going in the same direction, right? This current is also in the same direction, which means what you have to do? You have to put minus, what is the voltage? What is the voltage here? I through 2 ohms is the current and this is the resistance. You multiply these two, you will get voltage, right? So 2 into I through 2 ohms. That's all. You have reached the point A, right? Point A has been reached. Now what you can do, you know what is V over, right? Already we have found this. Now you substitute here, which is 3.34, and you just bring this 10 to that side. What anyhow I will write, which is equal to 10 minus 2 I through 2 ohms, right? So what you can do, you can bring this 2 I through 2 ohms to the other side. So it will be I through 2 ohms will be equal to 10 minus 3.34. I am getting like this. So I through 2 ohms can be written as 10 minus 3.34 divided by 2. Right? I can find what is the value I am getting. So I am getting anyhow I will write here I through 2 ohms, I through 2 ohms will be equal to 3.33 amperes. So you see we have found what is the current in 2 ohms resistor, right? And also you see it is very simple to find what is I through 1 ohms also, right? How to find this value? It is very simple. So how can you find? So you see I can take current in this direction and I am saying that it is I through 1 ohms. I through 1 ohms. Right? How can you find now? You we can you see I can start from this point and go here. That is also VAO. See, voltage between any 2 points via any path will be equal, right? So again I can go for VAO and through this path. So you start from this point, you go here, you see the current is coming opposite to the direction you are traveling, right? So what you have to do? You have to put plus, obviously it will be plus. And what is the voltage? I through 1 ohms is current and 1 ohms is the resistance. So it will be what? 1 into I through 1 ohms. Simple. It is very simple, right? This is 3.34, which is equal to 1 into I through 1 ohms will be I through 1 ohms. So what you will get? So I through 1 ohms will be equal to 3.34 amperes. Simple. It is simple. That is why I am telling repeatedly, please learn voltage between any 2 points via any path that will be equal. Anyhow, so we have found what is the current in 1 ohms resistor. And also, you see, I am just assuming the current here. This I am writing it as I through 3 ohms. How can you get this I through 3 ohms? Via you have to travel between O and A or O and B, because we know what is VAO and VBO. So you can approach through this to this 3 ohms resistor via VAO or VBO. That's all. So what I am going to do, since I know this voltage, since I know this current value, I can travel through this point to here. So I can write for VBO. VBO. So starting from this point, I will travel to this point. That will give you VBO, right? So if VBO, I am writing here. So VBO will be equal to, you see, I am going in this way, right? I am going in this way. So this current is coming opposite to me. So what I will get here? So that is plus 1 into I through 1 ohms. And you see, I am traveling here. The current direction is same as as my traveling direction, right? So what I have to do? I have to put minus, and what is the voltage? 3 ohms resistor, and I through 3 ohms is the current. So I can write it as 3 into I through 3 ohms. And you see I am traveling from plus to minus here. So plus to minus means you have to put minus. Voltage is 1. Voltage is 1 here. So I have reached point B. So starting from O to I have reached the point B. That is nothing but it is VBO. Now you substitute VBO. What is VBO? It is 2.40, which is equal to I through 1 ohms. What is I through 1 ohms? That is we found, right? Here it is 1. 1 into this 3.34 will give you what? Obviously it will be 3.34 minus 3 into I3 ohms minus 1. So you simplify this, you will get 2.34 and you bring this to other side. So what I will get, I'm going to bring this to other side. So I will get 3 I through 3 ohms will be equal to 2.34 minus 2.40. Right, now you see I will get I through 3 ohms will be equal to 2.34 minus 2.40 divided by 3, right? So what is the value I am getting? I through 3 ohms will be equal to minus 0.02 amperes. So you see, I am getting a negative value here. So what is the thing? The current direction you have assumed is wrong. That's all. You see, you directly put plus here, and this current direction has to be reversed. Has to be reversed, which means it will be in this way. In this way. This is I through 3 ohms. That's all. That like that you just change the current direction. Right now, I will take this point. What is this? So I through 4 ohms. So what I can do? I can straight away go to VBO. I will straight away get that what is VBO, right? So what is VBO? So I can write VBO will be equal to, start from this point, you go in this direction. You see I am traveling from minus to plus, then obviously I will get plus 2. And what is the this current direction is opposite to me, so I will put plus. And what is the voltage here? 4 into I through 4 ohms. 4 into I through 4 ohms. Now what you can do? You keep this. What is VBO? You know that this is 3.34, and you bring this 2 to other side. So you will get minus 2, which is equal to 4 into I through 4 ohms. So what you will get? So if you simplify this, so I through 4 ohms will be equal to 0.335 amperes. It is positive value. It is positive value. So what is that? The current direction assumed by you is right. So what I will do now, I will assume this is I through 5 ohms. What I can do? I can go in this way to B, right? So for starting from this point, go here, come here, and go there. You can reach point B. So that is also VBO, right? So I will write here. So VBO. So I will write here VBO, which is equal to, you see I am starting from this point coming here. So if I come here, what I will get? That will be plus 3. So what you are getting here? So if you are going from here, so it will be plus 3, and you see this current direction is coming opposite to you, right? So what you have to do? You have to put plus What is the voltage? 5 into I through 5 ohms. So 5 into I through 5 ohms, right? What is VBO? What is VBO? We found it is 2.40, right? So you can substitute 2.40, right? 2.40, that for VBO. You bring this 3 to other side, you will get minus 3 will be equal to 5 I through 5 ohms. And what you will get? I through 5 ohms will be equal to, so you will get minus 0.12 amperes. So you see, you are getting a negative value. So if it is a negative value, the current direction assumed by you is wrong. So this current direction has to be reversed. This current direction has to be reversed. And what is the current direction? It should be like this. So this is nothing but I through 5 ohms. And what is the value? You have to, what you have to do? You have to obviously you have to change this to plus. That's all, right? So you try to understand the current directions can be assumed by you. It is not at all mandatory to take. You see, we have assumed in this direction, right? But we are getting a negative value. Instantly what we have did, we have changed this negative to positive and we have reversed the current direction. It is very simple. That is why I am telling you uh, continuously that assuming current direction is not at all a tough thing in electric circuit. But so many students think that the current directions are very tough to understand. But you see, you don't value the direction of currents. Assuming current directions is totally up to you. Totally up to you. So you please follow this. And we have found all the currents in the resistor, right? So you see 2 ohms resistor is 3.3 ohms, 3.33 amperes, and 1 ohms resistor carries 3.34 amperes, and you can see this 4 ohms resistor is getting 0.335, and 3 ohms resistor is getting 0.02, and so many things. All resistors current we have found with a different technique. With a different technique. What we have taken? We have taken the nodal voltage analysis method. Right? So this is how you can solve the nodal voltage analysis method by matrix method. And we have not gone for the conventional methods. Conventional method in sense we are going to apply the Kirchhoff's current law. Anyhow, we will see nodal voltage analysis method by KCL. You see mesh current analysis method we have seen by KVL. By writing KVL, we have solved mesh current analysis method. The ultimate aim is to get what is the current in all the resistors. No problem, right? Likewise, for nodal voltage analysis method, you have to apply KCL, Kirchhoff's current law, to get the, again you will get what is VO and VBO, which means the node voltages. Right? We will see that. Anyhow, we will take another problem, which a complicated problem, so that you will get a clarity about this matrix method in nodal voltage analysis, where to find the node voltage, and by using the node voltage, we will get the current in all the resistors. Anyhow, we will see in the next class. Thank you.